Okay, this is concept 53. 53 being this sheet here. I do advise that you do not skip forward in any parts of this video because it's very easy to get lost and not know where things are being derived from. So first thing is I've taken this image here and I've blown it up here, okay, so that it's easier to see. So a unit circle is a circle with a radius of 1 unit. Because the value of r is 1 for each point p of x, p x comma y on the circle, the sine, cosine, and tangent values of theta will be defined as, what does that mean? Okay, so here's this image. I have some arbitrary right triangle that's in here, and I should have noted that please have, pause the video, please have concept 50 handy, especially that last section that I emphasized, right, the trig ratios of special angles. That looks like it's this page here where we worked with the special right triangles and we defined those trig ratios of those angles, because this remains consistent everywhere. So what I've done is I wrote them here, so you know they're just handy for the sake of this video. And what the unit circle is just applying these triangles into the circle and then being able to define the point p of x, y across all over the circle. Okay, so this first one here is my, again, an arbitrary right triangle. Here's my angle theta. Okay, and then you have to think, if this point here is x comma y, well, using this triangle here, I have my horizontal movement, right, creates this side here of x along the x-axis, and this here would be my elevation, right, my altitude. So that's your y movement going up. So then this point here is x comma y, right, because it does go across there as well. So p is x comma y. Now what we'll be doing, okay, so using that triangle right here, I have x and y, right? So then now I can define my trigs here, my trig ratios here, based off this triangle here. So sine, again, it's sine of theta is opposite over hypotenuse, so I have y over 1, that's equal to y. Cosine theta is adjacent over hypotenuse, so x over 1, and that's equal to x. And then tangent theta is opposite over adjacent, so y over x. Now this is very important because you might recognize something. Tangent theta is y over x. Y is sine theta. X is cosine theta. So this is our first, perhaps new maybe, but this is our first trig identity. Tangent theta is therefore equal to sine theta over cosine theta. Okay, so this one's key right here. So speaking of the point x comma y, you might have also noticed that the coordinates of p therefore can be written as, now what is it? I have sine theta is y, cosine theta is x, right? My point is x comma y, so then I can write the coordinates of p as cosine theta comma sine theta. Okay, and then I'm going to use this to define all the points across the circle using my special right triangles. So here are the special angles. The following angles are used frequently within the unit circle: 0, 30, 45, 60, 90, 180, 270, and 360. And of course there's other angles in between, especially here in the second quadrant, the third quadrant, fourth quadrant, but you'll see that we're going to use the idea of coterminal angles to be able to define the rest. Because the terminal side of 0, 90, and 180 and 270 angles lie on the axis, they are called quadrantal angles. So more on those in a bit. Okay, so we're gonna define our table here. What I have done in this column is I went ahead and I already converted my degree measures into radian measures. Now before you do this, or go ahead and pause the video and write these in, I do want you guys to look at it this way. Okay, we've already learned how to read angles here, right? You start at 0, you go counterclockwise, you have 90 degrees here, and then you would have 180 degrees here, you would have 270 degrees here, and then finally also, right, 360 degrees there. That would be one full rotation. If you recall, we also converted these 4 already into radian measures. Radian, right, 0 is just 0. I'm gonna use this pink, okay, to write in my radian measures. So in radians, 0 degrees is still 0. 90 degrees, right, if you have this written in, you know this is going to be pi over 2. 180 degrees, that was pi, right, and then 270 was 3 pi over 2, and then finally one full rotation, 360 degrees, was 2 pi. Okay, and let me make sure I get this on view here. There we go. So, and again, just think about how this makes sense, right? So if 1 half circle is pi, the measure of 1 half circle is pi. Therefore, a quarter of it would be pi over 2. And then if you add if you have the entire half, well, half a measure of a circle here, and you add another quarter, right, that would be 3 pi over 2. And then if you add the final quarter, that would be 4 pi over 2, which simplifies to 2 pi. Okay, now there are, again, other, based on our table here, you can find other radian measures, which we will do as we go through this video for all the other measures here. Now, the first triangle, and we did this one in class, I'm going to use red, is to define the 30, 60, 90. So, again, this first quadrant up to here is 90 degrees. So if I take the 30, 60, 90, if I'm trying to define theta as 30, you're going to have roughly about a third of this quadrant. So it'll go, let's say, about here. Okay. There. So this is my 30, 60, 90 triangle. And I've already defined in the past, that's why I said keep concept 50 handy. I already know what the trig ratios for 30 degrees are. So the sine of 30 would be a half, the cosine of 30 would be square root of 3 over 2, and then tangent of 30 would be square root of 3 over 3. So this point here, this point P, right, and remember that we just defined that all the points along the circle will be cosine theta, comma, sine theta. So using my angle of 30 degrees, I know that this point here, this first one, will be cosine of 30 would be radical 3 over 2, comma, 1/2. Okay, and that's it. That's the way this works, and we're going to be going all around. And the next one, the next main angle, right, and I'm using this here. As a matter of fact, let's fill in our table. So we just said that the sine of 30 was 1/2, and then the cosine of 30 degrees was radical 3 over 2. And then what's tangent of 30? Well, we could just use our first trig ratio here, that sine theta, tangent theta is equal to sine theta over cosine theta. So then a half over square root of 3 over 2. If you, right, I mean, I'll show the first one here. So, whoops, ran out of space there. Right, 1/2 over square root of 3 over 2. And then if you simplify all this, you should get let me see, 1 over radical 3, but we can't have that radical in the denominator, so you'll get radical 3 over 3, and then that checks out with what we have already from concept 50. Okay, and then of course the point, we said it was radical 3 over 2 comma 1/2. all right, next triangle we're going to use, I'll use blue, is the 45, 45, 90. So that'll be about halfway, and I don't want to necessarily overlap the first black triangle I drew here, so we're going to say it's, it's just above it, maybe somewhere there, like that. Here's my blue one. Okay, there's my right angle, and again this is a 45, 45, 90 triangle. Okay, and then here's going to be my point. That's the one I'm finding. So then, what is cosine of 45 and sine of 45? Concept 50, we already did it. We already did this triangle. It's going to be, they're both radical 2 over 2. So here, x, right, is cosine theta. Cosine of 45 is radical 2 over 2. And then sine theta, sine of 45, is also radical 2 over 2. And that's it. I found p of xy there. And my tangent of 45, well, we already said, right, trig ratio, sine over cosine. If you have radical 2 over 2 over radical 2 over 2, you get just 1. So tangent is 1 in this case. Okay, next one. I have the 60 degree. Now, the 60 degree is the same, where is it? It's the same 30, 60, 90 triangle, except it's just been flipped like this, right? We're gonna fit it in this way right here so that we have a 60 degree angle. If 30 degrees was roughly a third out of the 90, 60 degrees would be about 2/3 out of the 90, so it's gonna look something like this, about there. And we have this triangle here, okay, in purple. You guys can see that. Here's my 90 degrees. This one is now 30 up here, and then this one here is going to be 60 degrees. So then what is cosine of 60 degrees? Cosine of 60 is a half here, comma, and then sine of 60 is radical 3 over 2. Okay, and then so let's go back and fill this in. I know it's a lot of paper shifting here, but bear with me. So we already said the 45 degrees here were both radical 2 over 2, and then we saw that tangent of 45 was 1. So then p of xy is radical 2 over 2, comma, radical 2 over 2. And again, this is a coordinate point. Please put those parentheses. And then we just did 60 degrees. We saw that cosine of 60 was a half. So right here. And we saw that the sine of 60 was radical 3 over 2. Okay, don't get confused and put them in the wrong boxes here. And then the tangent of theta, tangent of 60 in this case, is radical 3. Now, again, the idea is it'll be sine over cosine, so radical 3 over 2 over 1/2. And if you were to just work that out, you don't have to, again, because you already did. You'll get square root of 3. And then this point here is 1/2, comma, square root of 3 over 2. Okay, so let's look at next rows we should do would be the 0 and the 90. So we said this was a unit circle, and the the idea is that the radius is 1, right? Now, just think about what that means for the circle. It's just logic, right? If the radius is 1, we know that in a circle, then the radius has to be consistent everywhere, right? Here the radius is 1, the radius is 1 everywhere. So right here at this point, right on the x-axis here, okay, what would be the coordinate point here? You'd have x is 1, right, because it's the length of the radius all the way here, but there is no y, right? You're right on the x-axis, so this point here is 1 comma 0 right there. This one up here is going to be 0 comma 1. This one here is going to be negative 1 comma 0, and then this one down here is going to be 0 comma negative 1. Okay, now knowing the labels of these points, I can find what the rest of these guys are, because I know this is cosine theta, this will be sine theta of the measure of the angle that we're talking about up here. So if this going all the way up here is 90 degrees, right, so then this is cosine of 90, sine of 90. So we're looking at the fourth row here. Let me see if I can fit both of them in. So fourth row here, cosine of 90 is 0. Whoops, wrong box. First column is sine, right? So cosine of 90 right here, cosine of 90 is 0. Sine of 90 is 1 right there. There you go. Tangent theta is sine over cosine, so 1 over 0, and of course 1 over 0 is something we can't do, so it is undefined. So there is no measure of tangent 90, okay? That's undefined. And of course my point here is 0 comma 1. Okay, don't confuse the order of the rows. This is cosine, this is sine. So 0 comma 1. Similarly, we can find the 0 degree or the 360 degree, right? Because it's the same. These are coterminal angles. So right here, cosine of 0 is 1. Sine of 0, cosine 0 is 1. Sine of 0 is 0. So sine of 0 is 0, cosine of 0 is 1. Tangent theta would be 0 over 1, and then that would just be 0. So the tangent of 0 degrees is 0. And then my points here would be 1 comma 0. Now let's look at 180 degrees. 180 degrees here, okay, it's cosine of 180 degrees, you get negative 1. Sine of 180 degrees, you get 0. So right here, first column is sine, I have 0. Cosine of 180, negative 1. Tangent theta, sine of 0 over negative 1, that would just be 0. So then therefore the tangent of 180 degrees is 0, and then the point is negative 1 comma 0. This makes sense, right? Because clearly you're right on the x-axis, so then therefore the y coordinates are going to be 0. Let's look at 270. 270, I have 0 comma negative 1, so therefore cosine of 270 is 0 there, and the sine of 270 is negative 1. And then tangent theta, tangent of 270 would be sine over cosine, so I have negative 1 over 0, and we can't divide by 0, so this one is also undefined. So there is no tangent of 270. And then here I have 0 comma negative 1. This table is our starting point to labeling the unit circle being the third page in your handout. That looks like this. Okay, now you've probably already been thinking about filling it in. I've been filling this one in, right? You have your points P x comma y all around here, and then what goes here, they want you to write each angle as a radian, right? So I've already done some of those for you, and I believe that's all we fit in to here. Yeah, that's it. And then more on this as we go through this video. So our table is complete. What I want to do now is show you how the logic works to fill in the rest of the circle. Okay, so I already fitted in my special right triangles here to define these points here. The rest of the unit circle is the same thing. Okay, now before I continue there, okay, maybe let's see, I'm gonna define what the rest of the angle measures are here. So again, 0 to 90, right? So halfway through is 45, 1/3 through is 30, and then 2/3 through would be 60. Okay, so I can go ahead and write, I can split each one of these. I can split pi, the radian measure of halfway here, pi, as for each respective angle measure here, right? So let me see, where's pink? Here's pink. So I can convert 30 degrees into a radian measure, and then that gives me what this is, what this angle is in terms of radian, right? So if the entire thing is pi, it should make sense that we are going to be cutting pi, or 180 degrees, in parts, right? This one is 30 degrees. So what is 30 degrees of 180? If you do 30 divided by 180 and you simplify, it's 1/6. So if the entire thing is pi, this one here should be pi over 6. So that one there is pi over 6. Hard to see. Let me circle it. Okay, that's the radian measure there. 45 degrees. If this is pi over 2, right, from 0 to pi over 2, if 45 degrees is halfway, half of 90, half of pi over 2, we'll divide pi over 2 by half, and then this one here would be pi over 4. Okay, and again, you can just use the formulas from before, from our previous concept, and convert each one of these, and you'll be getting these exact ones here. So what is 60 degrees in radian? Well, if 30 degrees was pi over 6, right, 1/6 out of the entire thing here of pi, what is 60 degrees? 60 degrees will be 2 pi over 6, or if you simplify, pi over 3. Okay, and another thing to look at it as is, well, this one here is 1/3. This entire measure here in radians, pi over 3, would be 1/3 of going all the way to pi. Okay, now this is a key thing to understand, because that's how I'm going to label these sides here. Now, to make things easier, I think it's better to start with the idea of the degree measure going to 180. So 30 degrees, so 30 degrees past 90, we have 120. So 120 will be approximately right here. So, and I'm going to use purple because if you can already tell, this one, this triangle here, is going to be, it's the same one that's on this side. Okay, here's my right angle, and then here is the theta that opens here is still 60 degrees. That's weird. Okay, 60 degrees, and then this one here is going to be 30. But right, you open 60, and then 30 more was 90. So then 30 more to get to 120 degrees. This one here, this entire angle here, would be 120 degrees. So then this here would be 120 degrees. Maybe I should have wrote it inside because it's going to start to get very crowded. And then if I add 45 degrees to 90 degrees, I get 135 degrees. That's going to be halfway through, so about here, and I'm using blue because this is going to be the same 45, 45, 90 triangle there. Okay, and then finally the red triangle, whoops, forgot to mention this one here would be 135 degrees. That one there is 135 degrees. Let me see. Yeah, we'll leave the measures reading out there. So and then finally the last one, it's going to be here, just about, there's my 90 degree, and then again this is a 30, 60, 90, so I have 60 there, 30 there, but then the entire angle measure will be all the way to here, right? So I added 60 degrees here to get to here, so this one is 150 degrees. So just to recap, this triangle was 30, this triangle here, the first red triangle was 30, the blue triangle is 45, the purple triangle is 60. Okay, now if I go all the way here, I got to 90, right? If I add 30 degrees more, I get to 120. It would be this guy here. Okay, but I can form the same 30-60 triangle that I have here on this side. Okay, but the entire angle going to here is 120. Then same idea. Okay, if I add 45 degrees now from 90, I get to 135. So 0 all the way to 135 here, and then I have the same, I can construct the same 45, 45, 90 triangle that I have here. And then finally, if I add 60 degrees to here, I get all the way to 150. This angle all the way to here is 150, so I can construct the red triangle from here, and it's the same one from this side. It's a 30, 60, 90. Okay, now here's where things can get a little tricky, but it's just logic. Okay, I already found these points here. Look, radical 3 over 2 comma 1/2, radical 2 over 2 comma radical 2 over 2, 1/2 comma square root of 3 over 2. If you use the idea of just coordinate points, look, so here's my positive x-axis, here's my negative x-axis, positive y-axis, negative y-axis. Okay, I can take these and you can verify, right, because you're still working with the exact same right triangles, guys. So this is 1, 1, 1. This here would be, 45, 45. The blue one here, that's x and x. You still have the exact same ratios. Okay, all that's going to change is your signs, because you're now in the second quadrant. You're in the negative x-axis. Your y's will stay positive. So therefore, the purple one here, if this was 1/2 comma square root 3 over 2, you're going to have negative 1/2 comma square root 3 over 2, because you're now on this side of the x-axis. Okay, it's going to be negative. And then here, this blue one, okay, you're going to have negative square root of 2 over 2, again, because you're in the negative x-axis, but the y is still in the positive side, so it stays the same, radical 2 over 2. And then finally, for 150 degrees, and you can verify in your calculators for all these values, and you'll see, again, negative x value, but the y value stays the same. So I have negative square root of 3 over 2 comma 1/2, and that's it. Just like that, right? Just using the logic of being in the positive x or negative x-axis and all that, we just labeled all the points going in the second quadrant. Now these points again stay the same in the third quadrant, the values at least. What changes is the sign. Okay, if you notice, okay, here it's the first quadrant, all my values are positive, right? Because you're in the positive y-axis and the positive x-axis. So here you have positive signs. Whoops, sloppy, sorry, because I'm looking at the computer feed here. Positive, positive. Here you're in the negative x-axis and the positive y-axis. Okay, so then I have negative x values, but the y stay positive. Okay, well, in the third quadrant, I'm still in the negative x-axis, but now I'm in the negative y-axis. So these are going to both be negative. Okay, and then the fourth quadrant here, I have positive x-axis now, so I should back into the positive there, but I'm still in the negative y-axis, so these are going to be negative. Okay, so from here, right, you can continue adding your angles. I'm gonna stop drawing the triangles. I'm just gonna still use the same color coding to show which angle I am talking about. Okay, so the purple was every 60 degrees, right? From 0 to 60, 60 to 120, and then from 120 to 180. So if I add 60 more, I get to about here. Okay, so there's purple. It's negative, or sorry, I started with 1/2 comma square root of 3 over 2, but again, I am now in the third quadrant, negative y, negative x, so then this guy here is going to be negative 1/2 comma negative radical 3 over 2. Okay, the blue, that would be adding again, so this one would be adding 45 degrees, so 0 to 45, 45 to 90, 90 to 135, 135 to 180, add another 45, you get to 225. So 225 will be, it's about halfway, right? So I mean, it is halfway actually. So right here, so the value is radical 2 over 2, radical 2 over 2. Here was the negative x-axis. Here, they're both going to be negative. So negative radical 2 over 2, comma, negative radical 2 over 2. And then finally, or the first one, right, radical 3 over 2, comma 1/2. This is a 30 degree. So I have 30, right? And then if you kept adding 30, 60, 90, 120, 150, 180, 210, that's this red one here. So 210 right there. This one's going to be so they're both negative now because I'm in the third quadrant, so negative radical 3 over 2 comma negative 1/2. Okay, and then just to pause a bit, right? So let me add the angle measures. I'm talking, let me see where's black here. So this one here was 210 degrees. This one here was 225 degrees, and this one here is 240 degrees. So what these mean is the sine of 240 is radical 3 over 2, negative radical 3 over 2. The cosine of 240 is negative 1/2. The sine of 225 is negative radical 2 over 2. The cosine of 225 is negative square root of 2 over 2. The sine of 210 is negative 1/2. The cosine of 210 is negative radical 3 over 2. Finally, the fourth quadrant works the same way. Okay, so let's do purple first. I add another 60 degrees and I fall somewhere here. That's going to be 300 degrees. So I fall, let me see, somewhere there. Okay, and this is the fourth quadrant, so my x's are now positive again, but my y's remain negative. So again, I started with 1/2 comma radical 3 over 2. So then now my x is positive again, so I have 1/2, positive 1/2 again, but this one is going to be negative radical 3 over 2. Then I have, whoops, I forgot to label the angle, so this one is going to be 240 plus 60. This one here is 300 degrees. Whoops, 300 degrees. Okay, so then blue here is let me see, about halfway. So 270 plus 45, I get 315. So then this one here is 315 degrees. So see, lost my train of thought here. Yeah. So radical 2 over 2, radical 2 over 2. My x is positive, my y would be negative. So radical 2 over 2, comma, radical 2 over 2, whoops, negative radical 2 over 2. And then finally the last one, I add, is my 30 degree, right? So I would go just before the full 360 turn, here. I have 330 degrees there. So then this point here is going to be radical, so right here, right, these guys, my x stays positive, my y is now negative 1/2. Okay, there, we just labeled the entire unit circle. Okay, please ask questions if you do not understand any of the original, for example, like the angle measures here, right? We have 30, 60, 90, and so on. It's like adding increments and fitting in that special right triangle in. When I was in high school, my teacher told me memorize the unit circle, memorize all these values going around. However, hopefully you picked it up, and I tried to emphasize or tailor the lesson to it. All you really need to know is the first quadrant, and then know the signs of each quadrant, because the values are, you know, the value of the point stays the same. It's just the sign that changes. First quadrant, they're both positive. Second quadrant, your x's are now negative. The x coordinates would be negative. Here they're both negative, and here they're positive and negative. X is positive, y is negative. So that's really all the trick to it. If you can memorize the first quadrant, you can do the rest of the quadrants, no problem. Hopefully the angle breakdown, the only thing I feel like maybe I didn't explain too well was just how the angles work, right? But if this is 90, you can break it up into parts, 30, 60, 90. If 90 is pi over 2, and again, you can just convert each one of these, and you'll see that those are these values here. Okay, so maybe the way we can wrap this video up is just find the rest of the radian measures of each angle here. Now, you could, like I said, you could convert each one of these using the formulas. However, I want you guys to just think logically, just cutting, knowing that half of it is pi, the full thing is 2 pi, and just cutting each thing into parts. That way you know it's a lot faster, you know what's what. So if the entire thing is pi, right, 30 degrees, 30 out of 180 is 1/6. So 1/6 of pi is pi over 6. 45 degrees, what's 45 out of 180? 45 out of 180 is 1/4. So what's 1/4 of pi? Well, pi over 4. 60 degrees, what's 60 degrees of 180? That's 1/3. So what's 1/3 of pi? Pi over 3. 90 degrees is half of 180. So then half of 180, half of pi would be pi over 2. And then the next one here would be 120 degrees. So what is 120 degrees of 180? Well, 120 over 180 you can simplify as 2/3. So this will be 2/3 pi. Okay, that's 2 pi over 3, 2/3 pi. Keep going. Okay, right here, 135 over 180. Okay, so what is that? That's going to be, so if this was 1/4 of pi, this is 2/4 of pi, which simplifies to pi over 2. This one here is going to be 3 pi over 4. And then of course, so then if that's 3 pi over 4, add one more fourth, you get the whole thing, pi. The next thing here is 150. So if this was pi over 6, right, and you were going all around, what's 150 over 180? 150 over 180, if you continue adding pi over 6, so this is pi over 6, 2 pi over 6 because it simplifies to pi over 3, 3 pi over 6 because it simplifies to pi over 2, 4 pi over 6, that simplifies to 2/3. This one here therefore would be 5 pi over 6. And again, that makes sense because 150 out of 180, if you simplify that, 150 over 180, you get 5 over 6. Okay, and you keep going. This one here would be 6 pi over 6, so it simplifies to just pi. Okay, using that relation for each of these, you can find the rest of these in their respective radian measures. So if you add, if we're talking 30 degrees, right? 30 degrees was pi over 6. So each of these is in terms of something over 6. So this is 6 pi over 6 because it simplifies to pi. So then this one here would be 7 pi over 6. Okay. And then this one here would be 11 pi over 6. Why? Because one more is 12 pi over 6, which simplifies to 2 pi. If I look at it as 45 degrees, right, so pi over 4, 2 pi over 4, pi over 2, 3 pi over 4, 4 pi over 4 simplifies to pi. This one here would be 5 pi over 4. And then the next one would be 6 pi over 4, which simplifies to 3 pi over 2. And then this one would be 7 pi over 4, because then the next one would be 8 pi over 4, which simplifies to 2 pi. Same thing, last one, 60 degrees, pi over 3, 120 degrees, 2 pi over 3, 180 degrees, 3 pi over 3, simplifies to pi. So then 240 degrees is 4 pi over 3. Okay, 4 pi over 3. 5 pi over 3. And then finally 6 pi over 3, which simplifies to 2 pi. Okay, so again, you can take it slow and convert each one, but again, I want you guys to see it by parts, right? If we're talking about cutting each thing into 4 parts, then we're talking about the ones over 4. If you're talking about cutting things into 6 parts, we're looking at the ones that are over 6, pi over 6, 2 pi over 6, 3 pi over 6, and so on. Okay, and then same thing with pi over 3. But that's it. I think we covered everything that is part of the unit circle now. So long lesson. We're still not quite there. We still have another page here. What I want to do is let's cut this one into parts. Hopefully you got the first page done, and then you can use, of course, the first page, our table, and my diagram I've done here now to be able to fill in your unit circle. And I believe everything gets covered, right? Yeah, you know what, I'm gonna leave this for you guys to fill in, because if you understood the whole thing with the signs, just knowing the first quadrant and being able to do the rest, you should be able to fill in these tables here. Okay, and yeah, we'll continue this in class in case there's any clarification needed.